All right, BC. So we have two free response questions, one from 2009, the other from 2008, that we're going to look at. Part A of 2009. By the way, both these are Form B, so make sure that if you are Googling your solutions, you look for Form B and not Form A. So interval of convergence, I'm going to assume the majority of you saw that phrase and jumped straight into the ratio test. There is another way to do this one, and I will work this out both ways, but because I assume y'all did the ratio test, I'm going to work it out ratio test first. It's going to be x plus 1 to the n plus 1 over x plus 1 to the n. And this reduces very nicely. There's one more x plus 1 in the numerator than in the denominator. So I have the limit as, I have a typo over there. I need to fix that. Absolute of x plus 1. And my typo I just caught is that this limit is as n goes to infinity, not as x goes to infinity. So I need to fix that. There we go. Now in this limit, keep in mind that the limit is as n goes to infinity. That means x is a constant. There is no n here. The answer to this limit would be absolute x plus 1. And then for the ratio test to show convergence, we need the answer to be less than 1. So that's going to be when negative 1 is less than x plus 1 is less than 1, which gives you an interval of convergence of negative 2 less than x less than 0. Yet now we need to test those endpoints. So I'm going to come up here and I'm going to test my endpoints starting with negative 2. If I test x equals negative 2, I would have the series of negative 2 plus 1 to the n, which is negative 1 to the n, and negative 1 to the n power from 0 to infinity. Those terms do not approach 0, therefore that will diverge. Then I need to also test x equals 0. And when you do that, you will have a similar series, only it will be 0 plus 1 to the n, which is just 1 to the n. And again, my terms are not approaching 0, so we will diverge at the right endpoint as well. So that means my interval of convergence is going to be negative 2 to 0, not including either one of them. So there's your ratio test approach. It works perfectly fine. However, you always want to look out for one little gift, and they gave you a gift here because this series, x plus 1 to the n, is a geometric series with a ratio of x plus 1. And if you want to look at it from the perspective of a geometric series, we could say that a geometric series, converges when the absolute value of the ratio is less than 1, which will end up giving you the absolute value of x plus 1 is less than 1, which we've already shown over here that answer ends up being negative 2 to 0. Now, the amount of work on the ratio test to get to that same point really wasn't that much. However, in a geometric series, the geometric series absolutely diverges, or certainly diverges, when the ratio is equal to 1. So if you recognize it as a geometric series, you don't have to test the endpoints, and there's where you're going to save a little bit of time on a problem like this one. So look out for that. Ratio test works fine. However, if you recognize geometric series, it makes things a little bit easier for you. And part B says the power series above is a Taylor series for f about x equals negative 1, which hopefully you may have recognized that because it is centered at negative 1. And here is a huge hint that could have gone back and helped you with part A. Find the sum of the series. There are only two types of series that we could sum. One was a telescoping series, which is not on the AP exam. The other is a geometric series. So if they ask you to actually find the sum, they are telling you that it's geometric. Okay, I lied just a little bit. There is a third category of a recognized series, which we'll go into in more detail a little bit later. But if you see find the sum, that phrase right there, start by considering a geometric series, and this one is geometric. And so the sum is your first term over 1 minus the ratio, which means the sum here is going to be my first term, 1 over 1 minus the ratio, which is x plus 1, which ends up being 1 over negative x. So there is the sum of the series. And this shows up later in part C and D, but the sum of the series actually would be the function f. So we now actually have a traditional function for x, so for f. So f of x actually ends up just being negative 1 over x. It doesn't come into play for this one. However, it does help you with parts, either part C or D. I can't remember which one. So let's move on to the 2008 question. Those are the only two parts I wanted to do for the 2009, 2008. And this is a throwback to something we did before coronavirus killed your senior year, where you are given a function and they want you to turn it into a series. Now, when we did this earlier, I didn't call it a Taylor series. I called it a power series. But a Taylor series is a power series. And what I can do here, excuse me, what I can do here is instead of doing the derivative approach where we have to crank out derivatives, this looks an awful lot like the sum of a geometric series. And if you look at it that way, the first term is 2x, and the ratio would be negative x squared. And so I could write this as a series, and it goes from 0 to infinity, of my first term, 2x, times my ratio, negative x squared, to the nth power. And then I'm actually going to clean that up a little bit. That's going to be the series of 2x, negative x squared to the n is negative 1 to the n, x to the 2n, and then I can even go one more step to clean this up. 0 to infinity, that'll be 2 times negative 1 to the n. X times x to the 2n would be x to the 2n plus 1. And so I have a series in sigma notation. However, they did ask for the first 4 non-zero and the general. So my first 4, I'm going to say f of x is approximately, a Taylor series is an approximation for the function. Taylor series for this would be, and I start plugging in my values of n. So my first term would be 2 times negative 1 to the 0 times x to the 0 plus 1. So the first term is 2x, which I knew way over here. My second term, plug in 1 for n, and I see that this is going to alternate, so I actually need to go back and erase that. My second term will be negative, and that will be negative 2x cubed when you plug in 1 for n. And then at some point, you're going to recognize the pattern. We are multiplying by negative x squared each time, so I could just do that. So it's going to be plus 2x to the 5th minus 2x to the 7th. There are my first 4 terms. It does ask for the general term, so I'm just going to say plus dot 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 plus, and then my general term was 2 times negative 1 to the n, x to the 2n plus 1. And the series does continue, but there is your answer to part A. Those are your first 4 non-zeros plus the general term. And then for part B, does the series, shrink my head up, I can't read the question. Hey, does the series found in part A, when evaluated at 1, converge to f of 1, and explain why or why not? So I'm going to go back, and here's where some of my preliminary work in part A comes in handy. This right here, why did it group it that way? Whatever. That is what I'm going to look at. So let me paste that. There we go. And erase all this mess over here. Okay, so there is the series for f, and they're asking about f of 1. So f of 1 would be the series n equals 0 to infinity, 2 times negative 1 to the n times 1 to the 2n plus 1, which will be the series 2, -1 to the n, because 1 to the 2n plus 1 will just be 1. So there's your series, and now I'm looking at this, and I can tell that this is geometric with a ratio of -1, and a geometric series will only converge when the ratio, absolute value of the ratio, is less than 1, and this is not. Therefore, this diverges. And the question is, does the series converge to f of 1? And we say no, it does not. So explain why or why not would be right here. Geometric series with r equals -1, and the preliminary work is my explanation. And so there, I believe that's the last one I wanted to do. It is. So there are those two problems. Hopefully that made some sense for you.